Hi, I'm here to briefly discuss opiates and opioids, their mechanism of action, terminology surrounding it, as well as discuss one opioid receptor antagonist used clinically to reverse the effects of opioid toxicity. Opiates and opioids are derived from the opium poppy plant, which has been historically used for its medicinal purposes. Now, there is a distinction between opiates and opioids. Opiates are made from the opium poppy, and this is morphine, whereas opioids are synthetic drugs, and they're morphine-like, but they're stronger, such as fentanyl. Opioid receptors can be found in the G protein coupled receptors, and these receptors have different subunits or subtypes, with mu subtypes being targeted most by opioids. And so the mu subtypes is also responsible for all the clinically observed effects of opioids, such as the pain relief, the euphoria, the constipation, and the dependence. We have these pain receptors, pain transmission pathways in our brain that senses painful stimuli and transmits pain signals to the cortex and modulates pain signals and how we feel pain. But with the presence of opioids, opioids reduce both the sensory and emotional components of pain, the affective aspect of it. And so while a person might still feel pain, the discomfort to that pain is lessened with the presence of opioid. Seen here is depicted here is the synapse in the dorsal horn of the spinal cord, and how the specifically mu opioid receptor agonists such as morphine can inhibit calcium channels. Now, with the inhibition of calcium channels, you see a decrease in the calcium influx into the cells, which decreases neurotransmitter release, subsequently increasing potassium conductance. With an increase in potassium conductance, you see an increase in potassium flow out of the cell, leading to hyperpolarization, which means that the neuron is less likely to fire an action potential. And so an increase in potassium conductance can lead to inhibitory postsynaptic potential, as we can see here. Now, with the closed calcium channel coupled with the open potassium channel, you'll see an inhibition of neurotransmitters that ultimately lead to the analgesic effects of opium. Seen depicted here is the naloxone nasal spray. Now, while it does depict that the naloxone can also be administered intravenously or intramuscularly. And naloxone is a pure antagonist, meaning that it competitively binds to opioid receptors, displacing the opioid, and that can reverse the respiratory dependent depression and overdose. And it's also there's also zero bioavailability in naloxone, which means it doesn't reach our bloodstream. And so it's a critical tool used right now against the opioid crisis. And it goes without saying that opiates and opioids, the dependence and tolerance increases as you use it more. And so it's best to listen to licensed clinicians when it comes to these types of drugs.